Okay, so today we're doing our last form of factoring, which is called lead coefficient factoring. So we better hope we're going to put it all together tomorrow, and then we're going to start using all of this factoring. Okay, so lead coefficient factoring, when you have the formula ax squared plus bx plus c, is where a is a number greater than 1, is any integer greater than 1. Okay, so we can look at our first example. We've learned that if we double distribute, we get it. When we have two binomials, we end up with a trinomial, right? Well, now in this chapter, we're starting with a trinomial, and I'm asking you to factor. So here's the steps to factoring with a lead coefficient. I think it's the quickest, most efficient way. So we start with our lead coefficient. What is it? 2 in this case. Our a is 2. And we are going to multiply it by the constant term c. Okay? So I'm going to take that 2 and I'm going to multiply it out and multiply that 15 by 2. And what does that make? 30. So once I do that, I'm going to rewrite it as x squared plus 13x plus 30. Now I multiplied the lead coefficient out with the constant term, right? Now I can say what multiplies to 30 and adds to 13. What multiplies to 30? Yes.
Never mind.
Yep.
10, 3.
Positive 10, positive 3. And now we're going to factor like normal. Okay? So we have, what's the root of x squared?
X.
So I'm going to place an x and an x. And now I'm going to do plus 3 and plus 10. But now, we said that we multiplied the 2 by the 2. Now we're going to divide the constant by the 2. We got to keep it even in math, right?
Yeah.
If I multiply it, then I got to divide it and take it back. And I'm dividing the constant terms by what? 2. Okay? Now, if that fraction there can be reduced, you reduce it. If it can't, then I'm going to show you what to do. So now my new, on this first term, 3 over 2 can't be reduced. So I'm going to take that 2, and it's going to be the lead for the first binomial. 2x plus 3. Okay? Now the next one, it simplifies. 10 over 2 simplifies to what?
5.
X plus 5. Okay, now, what's going to be really important is that you check yourself, because you could be really off. But especially if you have time during a test, you need to be checking. And so the check is to just double distribute back. Now, make sure you're boxing your answer. So you don't come back and give me the check in the answer column. Does that make sense? The check would be to do 2x times x is 2x squared. 2x times positive 5, I'm double distributing, guys. The outside terms is 10x. The inside terms is plus 3x. And then the last terms is plus 15. So we have 2x squared plus 13x plus 15. Does that make sense? Questions? Okay, can I move on? All righty. Okay, want to try another one?
Yes.
I know this is uncomfortable. Let's just try another. Let's try the next one. Ready? I'm starting with my 3, and I'm going to get rid of it by multiplying the constant term by that lead coefficient. So what does that become? What does my new line become, Yaakov?
X squared plus 3x plus 4x
Plus 12. Yeah, I'm not multiplying by 3x squared, just the 3 by the 4. Okay, now what multiplies to give us
6 and 2.
12 and 8? I heard a 6 and a 2. All right. So what is this factor to? Yep.
X plus 2 times to the quantity.
Times the quantity
of x plus 6.
Good. And now, what's my last step that we can't forget? Divide the constant terms by 3. Now, Yaakov, what happens here?
Becomes
Plus,
plus 2
good,
times the quantity of
x plus 2. Okay, I'm going to double check it. 3x times x is 3x squared. 3x times 2 is plus 6x. 2 times x is 2x. 2 times 2 is plus 4. 3x squared plus 8x plus 4. Is that what I started with?
Yes.
That is my check. This is my answer. Okay, questions?
How come you divide like 3?
So I just had a question. Why was the last one 2 and this time it's 3? The last time it was 2 because the lead coefficient was 2. This time it's 3 because my lead coefficient is 3. Okay, let's go on to the next one. Yes?
If the lead coefficient is nothing, if it's just x, would you not multiply?
Then we just do x marks the spot.
Yeah.
Like that was regular trinomial factoring. Okay, so let's try another 2. If you know what to do, go ahead. And if you still need help, let's wait a minute. Let me give people a chance. Okay. Ethan, what's the lead coefficient here in number 1? 3. What am I going to do with that 3?
Multiply it to -4.
Good, and that becomes a?
-12.
And I'm going to rewrite everything else. Okay. What multiplies to -12 and adds to -11, Nathan? Ethan? Aaliyah?
1 and -12.
1 and 12, or -12 and 1. So what does this factor to, Ethan?
It factors to x or
X.
x minus x plus
You just said minus. Okay. I'm writing what you say. So x minus what?
-12.
Good. And?
X plus 1.
Good. Okay, now what's our last step in the process? I multiplied by 3 here. So now
By 3
I have to divide our constant term by 3.
and repeat x.
No. Oh, yeah. The first one's going to be what?
X minus 4.
4.
And the second is 3x plus 1.
Okay. And I want you guys to double check it. Okay, questions? What? No, we can't keep going there. Dariush.
To keep it in like the same pattern, can we have like the x plus 1 first? So it like, cause
3x plus 1.
you know like we had x, the quantity of x minus 12 times the quantity of x plus 1. Then
Yeah, I don't care which one you do, -12 and positive 1.
okay.
Okay. You ready for the next one? Ethan Harmon, what am I doing?
Okay, so you're gonna just multiply the 2 to the 10.
And then what do I get?
You get x squared minus 9x plus 20.
X squared minus 9x plus 20. And then?
You're gonna have to find 20 and then not -9, which is
Okay, who has the factors? Thomas? Negative 5, negative 4. So what does that factor to, Ethan?
That factors to x minus 4 and then x or minus 5 and then x minus 4.
Okay. And then
You're going to divide by 2.
divide by 2, divide by 2. And we end up with
2x minus 5 to the quantity of x
times the quantity.
times the quantity of x minus 2.
Perfect. Okay. Double check it. Are you checking it? Double distribute. Just do a mental check. Yes, that makes 2x squared. This is, I really check my middle terms. Minus 7x, minus 5x, minus 4x. Yes.
Oh, is there a specific way, like a specific order? It doesn't matter if you put x minus 2 and then 2x minus 5?
No.
Or, okay.
No, it would be here would be your order.
Oh, okay.
You're going to keep the order based on what's right above it.
Yeah.
Okay?
What if it was just like x minus 4 or x minus 5?
Okay, so let's do, the order really is here. So if I'm here, I get x minus 4. If you want me to go this direction, that order, minus 5, it doesn't matter which one I do.
Okay.
But now, when I'm dividing by
2. It has
by that 2, by the 2, this is just an extension of this. X minus 2. 4 divided by 2 is 2. And this doesn't divide, so I put it as 2x minus 5. So it would really be about that order. All right, you want to try 2 on your own? Let's try them. And, try the next 2. Pause the recording and try the next. All right, so what are we doing first? Let's go Toggenburger.
So for the first one, you would have distribute 2.
We're not distributing. Don't call that distributing. That's totally different. Distributing is when you have like 9 plus x over a plus sign and parentheses.
Okay.
So I'm getting rid of it by multiplying the lead coefficient by the constant term. And what do I get?
X to the second power minus 7x minus 60.
Minus 60. So we said what multiplies to negative 60 and adds to negative 7.
Nothing. So,
Yes, it does.
Oh, wait.
Okay, guys, you got to know your multiplication facts. Here we go. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and,
12.
okay? Those, it could be add or subtract, Kayla. Which one needs to be negative in order to make the 7 negative? Right, the bigger number. Negative 12, positive 5. You need one negative to make this negative. So now how do we factor this, Toggenburger?
So you have to x plus 5
Good.
and then x minus 12.
Perfect.
And you have
Now what's my last step?
to divide both of them by 2.
Divide by 2, that lead coefficient that I started with. And on the first one, what am I going to get?
You move the 2 in front of this x, so it's 2x plus 5,
Good. And the other one?
x minus 6.
X minus 6. Did you guys check it?
Yes.
Is this the answer you got? Okay. Next one. What are we doing?
I have
Yes.
a quick question. So when you have the
Shh.
let's say you have x plus 5 halves, would you, let's say it was 10 fourths, would you simplify?
Yes, you have to reduce
You
that
have to
first.
reduce-
So if you had something like
Oh, okay.
x plus 10 fourths,
It would.
say this were what I got. What I had, sorry. And we got to reduce that fraction first. 2 goes into 10, 5 times, and 2 goes into 4, 2 times. Do you understand?
Yeah.
Because if you went 4x plus 10, you haven't factored completely. Okay?
Okay.
Okay, next one. What am I doing? Who wants to? Okay, how about Jake? I haven't heard from Jake.
So in this case, you would equal to 6 and then x squared minus 17x plus 72.
This is exactly the problem that we need that on, huh?
Yep, that's why I asked.
Okay, now what is this factor to?
No, I use negative 9 and negative 8.
Good. Your x marks the spot. Hold on. X marks the spot. We need positive 72, negative 17. So, Kayla, notice I'm putting where's positive 72 on top, negative 17. And so he's saying what are the two numbers that add to negative 17 but multiply to negative 72?
It's negative 8.
And?
Negative 9.
Yep. Good. Keep going, Jake.
Okay, so then after that I had a little trouble because then
What's the root of x squared?
x. So
X
otherwise,
times x.
x minus 9 plus, times 1 and x minus 8.
Good.
Like that. And then I divide, no.
Yeah.
Yeah, I'm going to divide it by 6.
Divide by that 6. Now, the thing is, you got to reduce these. Or it's going to be, what do you think?
Can I see the answer?
No, what do I do here when I reduce it? What does it reduce to?
Oh, it reduced to negative 4 over,
No, right here. Look what I'm looking, look at me.
negative 3 over 2.
Or 3 over 2. Because I'm dividing 3 out, I'm left with 3. I'm dividing 3 out, and I'm left with a 2. So what does that become?
2x minus
2x minus 3. Now I have to reduce this one. What number divides into both? 2. So in the top one I'll be left with a 4, and here I'll be left with a 3. And so what would that final part be? 3x minus 4. So do you understand what to do if you have a fraction like 8 over 6? Reduce it first. Because when I reduce it, I'm really divide by 2, divide by 2. I'm multiplying or dividing by 1, it's the same thing. Identity property, right? Doesn't change its value. But you'll be fully factored. Yes?
Would you still multiply the coefficient by the last number if the numbers were like really big?
Yeah. Well, I mean, sometimes you don't have a choice. You're going to get big numbers. Okay, can I move on? So are you guys okay with the reducing of the fractions within? Yes? Okay, let's go to a couple different things. Actually, I guess I want to address that, but then I want to go to a couple other exceptions. We've got about 10 minutes, so I want to make sure and hit all of those. The big numbers, because you're going to get big numbers, and that's where it's going to get really frustrating for you. But let's put it all together now, because we've been doing this, now it's our last day. Now we're going to add all the multiple steps to it. So step 1, what would I do? Find a GCF, I heard. What would be the GCF?
2x.
Perfect, 2x. 2x. So I'm pulling out my 2x, and I'm left with x squared minus 13x plus 10. Is everybody clear on that? Okay, now, just that piece, okay, I'm left with some lead coefficient factoring. What would I do, Aaliyah? Before that, what do I do with the 3?
Oh, multiply by 10.
And what am I left with?
X squared minus 13x plus 30.
Now, the biggest thing to remember is that you remember your 2x, the GCF. Right? Now, what multiplies to 30? Kayla, and adds to negative 13. How about Maggie? Negative 3, negative 10. Okay, and so now we are, I have to break this down by what? What does this factor to, guys? X minus 10 times x minus 3. Okay, next. Now what would I do? Divide by what?
3.
By the 3. Divide by the 3. And we finish with 3x minus 10. And the other one is times x minus 1. So my overall answer would be all of this. Now my suggestion here for your checking would be check this. Check that you end up with this. Or that you end up, sorry, with not that. Hold on. That you end up with this right here. Because then you can mental math the rest of it. You know? Okay, next one. Okay, what do you think we do? Is there a GCF?
No.
Okay, we move on. Good. I'm glad it was the first thing you checked. Okay, Charlie?
Then you multiply the first coefficient, which is 4, by the constant term.
And we get?
We get 16.
Good, so it would read x to the...
4 minus 17x squared plus 16.
Okay, now I've got 16 and adds to negative 17. How about negative 16, negative 1? And now, how am I going to factor that, Charlie?
Then you have x squared.
X squared, because the root of x to the fourth, Jake, the root of x to the fourth is x squared.
X squared minus
Uh-huh.
1.
Minus the 1 and...
And x squared minus 16.
Good. Now, I had that all right there. Okay. Now, what's that last step that we remember? Divide by the what?
4.
4, divide by 4. The first term is going to be what?
4x squared minus 1.
Times x squared minus 4. Now, am I done?
Nope.
Why? Because we're left with a difference of squares. So the first one is going to factor 2. I'm going to have a plus and a minus. 2x plus 1, 2x minus 1. The next one is going to be what? So all of these binomials are part of the answer. I mean, you need that whole thing. Now, somebody said to me, question?
Isn't that second binomial thing a difference of squares?
We did it right here.
No. The answer.
Right here? Yeah, but I still wanted to get rid of this divide, finish.
The 2x minus 1.
No, that's not a perfect square. We can't break.
Oh, yeah.
2x is not a perfect square. All right. But how do you check? So my student said to me, wow, that's a lot to multiply. Multiply those two together, you should get that. Multiply those two together, you should get that. Really, if you multiply these two together right here, you should be able to get this. No, you should be able to get this top one here. Does that make sense? Yes. No. Okay, next. We are on our last one. I want you to... You're going to have big numbers, guys. I'm going to show you how to deal. Shh. So,